Hey everybody, John Grimsmo here, and this is our Willemin 408MT. It's a 2004 model, and I bought it almost a year ago. And it came a few months after that, and then we were all excited and we ordered the LNS bar feeder, kind of got it settled, got it all put together. Took many months in order to get the power to it, and we've had a lot of other projects on the go. And then we finally got it started, and then there's little alarms and errors that we've had to get through, so fix the fans. We've got some other videos about how we did that. And then from there, bit by bit, we just kept testing things, do a tool change, see what works, do the swivel, see what parts we're missing, what parts we need. It did come out of a running shop, but after things kind of sit for a year, things need to be loosened up and replaced sometimes. Where I'm at right now is 2 months ago, I thought I was done, I thought it was working, I thought it was good to go, and then while swiveling the B axis, the spindle, 0 to 90 degrees, it would give me this weird alarm that I couldn't figure out. So I got on the phone with Willemin, and it turns out it is most likely this cable harness. This little broken wire right here is my theory, or it's one of the ones in here. This wire goes through the whole spindle housing and connects to the spindle. It measures your RPM, your spindle position, various features like that. This wiring harness needs to be replaced. So I have a new one here. And a couple months ago, I tore this all apart, removed the spindle, put it on the bench, figured it out, got all the new parts in, and now 2 months later, I've kind of almost forgotten how everything goes back together, but I'll figure it out. So my goal by the end of today is to have this stuff back in the machine and hopefully power it up and see if it works. Okay, so what's all this stuff called? Transfer plate, new wiring harness, hydraulic hose, metric O-ring, housing, spindle, stuff, thingamajigger, slidey thingy, custom-made spindle liners, wrenchy thingy. Now, you may be wondering, why didn't I hire a professional to come in and do this replacement? A lot of times that's what happens with Willemin machines. I was talking with Marcus from Willemin, and he said almost nobody does this spindle removal themselves. He's usually the guy that travels around, but because we're in Canada and they're in the US, and we're still in COVID times and the border is still tricky to get through, and that's one of my big reasons why I haven't pushed that. Travel from the US to Canada is iffy, not impossible, but that and a bit of the cost. I don't mind paying the cost to have it done. I guess, I don't know, I was put off by that, and also I'm stubborn, and I figured I could do it myself. I know I can do it myself, but at the expense of it taking months and months. Now I just got to put the hydraulic line in that counterbore we machined into it. Yeah. This way or the other way? I think it was this way.
Probably figured this out.
Yeah, I know, right? That's what I was saying. I totally forgot.
Yeah, everything built off from the back here.
Okay, so it goes this way. So I'm sure I'm not the only person who's had a project sitting for months and months, and I'll get to it, I've been meaning to get to it, I'll get to it. Well, that's where I'm at right now. So this right here is the spindle housing. It's heavy, but it's not that heavy. I thought it would be a lot worse. So your tool would go here. This is your spindle, your cutting tool, your drill bit, your end mill, whatever. Coolant goes there. And it's kind of sweet how this whole thing comes out. And that DB25 connector, like this whole thing just clicks into the transfer plate, and you get power, like this is power to the spindle motor. That's what this thing's for. This goes on the other side. These are transfer connectors for various air and coolant and lubrication and cooling fluid that goes through. And you got your locating pins, your round and diamond pins here. Very nice surface ground flat face. And it's a really sweet kit. This spindle, actually, it's really interesting. On this machine, after so many years, 15 years of hard use, usually the spindle is one of the big replacement things that needs to be replaced, and this machine had this replaced about a year ago, and only a few months before they tore it down and sold it to me. So this spindle is brand new, and it was like I think it was $15,000 or $30,000 that they paid to have this replaced. And I'm glad I don't have to do that because it came with the machine. So there's a good package for us. So this is going to go here. Look at that fit. And then all of the stuff, all of the guts and brains are going to come up out of it. So this aligns everything so that all the hoses and everything go in where they're supposed to be. And notice it's got a really nice radius here so that as the wires are, you know, on the edge of it, they're not scratching. Okay, so here you can see how the big connectors and the power wires are potted into place to keep them in place, all zip tied around the posts. They go up through this column with all the hoses and everything. It's a tight fit. There's a lot of data and fluids and air that are going through this. Thank goodness I took a lot of pictures as this thing came apart so that I know now which one goes to which. So what I'm trying to do now is I'm trying to figure out where all the hoses go. These two are your cooling fluids. They provide chilled coolant to the spindle. This is one of your hydraulic lines. And I know there's another hydraulic line. I don't know where it is though. So this is the part I was worried about. I'm test fitting through the bore. It's got to make a hard 90 at the back and go out this little gap in the side. And even just with this one thing, it's being annoying. And how on earth am I going to get 20 wires, 2 hydraulic lines and 2 cooling lines through this? This end goes to those 2 lines right there. And all I need is this to be long enough so that I can remove the spindle or put it back in. Well, the good thing is there's plenty of line, so I'm going to make 2 pieces this long and then we're good. Welcome to day 2. So yesterday I basically got this done. Angelo and I got this all strung up. We had to align the hydraulic hoses so that this sleeve will fit perfectly over top of them, and figure out the length and the orientation of all the vacuum hoses and the electrical wires. And also I used black RTV, silicone sealant, to pot the electrical components and all the stuff, the little tiny vacuum hoses, because that's how the old system was, so that they don't wiggle around and they stay stationary. It looks really gross and messy. It looks like I didn't know what I was doing, and I used the dental pick to like tamp it down, but every time you tamp it down, it just loops back up. So it just didn't settle, but it's fully functional, it looks great, works great, might not look great, who cares. So today I only have about 45 minutes, so I'm cleaning up this face, and then I'm gonna zip tie these things together in the right orientation so that they're ready for tomorrow. And it's the weekend now, so maybe on the weekend I'll come in, try to install this thing, or maybe I'll wait till next week, I don't know yet. But I want to clean up the mounting face because there was some leftover silicone on there. So I've got my precision ground flat stones from Spencer at Kinetic Precision. So these are Norton aluminum oxide stones, like machinist stone, but he puts them on his surface grinder with a diamond wheel and makes them ultra, ultra, ultra flat, so that they are just 2 incredibly flat surfaces. And you have your coarse side and your fine side. You ring them together, and I can feel there's dirt and grit in there until, oh, it feels so good when they're clean. So you do that, you clean them up. I'm gonna use the coarse side. And then if there's a nick in this surface, you can stone it out with that nick. And these stones, because they're so flat, they're not actually abrasive anymore. He has cut off all the abrasive high points of this stone so that it, on a flat surface, it skates, it glides, it feels amazing. It is not cutting absolutely anything. But if I put a nick in here, like I shouldn't do that, but whatever, I'm fine. Oh, I can feel it scraping. But now I know I can scrape that down. It's feeling better, it's feeling better. And now I know we have a flat surface. So you can actually see where the stone is smoothing out that surface. So for all intents and purposes now, this is still a flat surface. So the machine now doesn't care that there's a nick there. It is a flat surface. So this, basically all the umbilical cord will be going into the spindle, kicking out the side, plugging into the back. This face is where the spindle goes. Angelo came up with this great idea. We took a piece of plastic, drilled 2 holes in it for these hoses to come out. All this black goo here is our black RTV, but the plastic here that we taped in allowed me to create a little swimming pool, filled it in from the back, We tried to remove it today, but it was still really goopy, so it's not ready. I'll give it a couple days. But that's okay, because I can still install this into the spindle once I have time and help and stuff. Might be next week, even while this is still here and curing. But that's the next step. Once this is ready to go, it's going in there. This will be exposed, and then the entire spindle cartridge will bolt onto here. Your electrical connections, your signal, your power, some vacuum lines will connect to that. So here is some of their documentation on how this all goes together. I'll have to look very closely. So this one goes around, everything, and then some closer ones here. Okay, those two, that gets done. And here's how they potted it, very similar. Okay, I know what to do. This maintenance card right here is something that Angelo's been pushing on for years. We finally got it in this new shop, and it's been incredible. So we've got the one container for zip ties. We've got a container for all the random crescent wrenches. We've got one for O-rings, one for random bearings, electrical components, huge bunch of sections on our plumbing fittings, air lines. It's been just great, and the whole thing wheels around. So while I'm doing this, I want to make sure that the big end is inner of the OD, because I know this thing's got to slip in. So if I put the big fat part on the outside, it's not going to fit. So just little things to keep in mind while I'm doing this. I want to make sure not to pinch the vacuum hoses, while also keeping everything where I want. So I figured out what the two small lines are specifically for, because I asked Willemin last night when I was texting them. One of them is for positive pressure in the spindle housing. So this literally just feeds in and kind of goes into nowhere in the spindle housing. But what it does is it creates a positive pressure zone so that air is constantly leaking out of the bearings, so no dirt and garbage and stuff comes in. So every open surface, there's probably only two, like rotating sealing surfaces, are now gently purging air. The current does the same thing. You can see coolant bubbling up from the round seals. And then the other one is for a taper blast. So every tool change, it blasts a gentle stream of air. If this was a tool holder, which will clean any chips off theoretically as it's doing a tool change, so that chips don't end up on the mating surface. So now I know what those are for. The two big ones are for cooling fluid, antifreeze basically, and then various two hydraulic hoses, and then power, and then signal. There's a lot of signals that do a lot of things. I had an idea. I had a brain blast as we were just wrapping up, put the mics away and everything. What if I loosely bundled this together into a thing, maybe took my blue tape and just, something loosely, and literally tied a string to the end, and I can feed the string through once, and then as long as it'll clear and I'll make the corner, I just pull on the string, and then the whole thing comes through. So next week I'm gonna have to try that, because that might be the easy way to do it. Imagine trying to shove them one by one through that hole and around. It's gonna be a mess. We're gonna have to pick it through with a thing, because it's they come out here. And that's, I don't know. It might work. I'm gonna try it. Close up these hydraulic lines, because as I shove it through that hole, I don't want little bits of goo to get inside these lines. And what I realized is once I get it in and through, even if I put tape or a zip tie or something here, it'll stick out the other side, so I can always cut it off or remove it later. This joint here is a swivel joint, and now that it's all together, I see why. Because the wiring is going to make its 90, and this thing's going to go 0, 90, 0, 90, 0, 90 all day long. And you can see, I'm glad that swivels, because it really works. And you can see how all the other hoses are going to interact. Everything turns the wrong way. It needs to go in like this, and all the cables are bending naturally the wrong direction. You're supposed to struggle in videos, right? Come on, tape. What if we tie the aluminum wire to this? Would that work? So we might still need another one to fish it through. A longer one? Almost got it. Okay, pull it out a tiny bit. Push it in. Wait. Okay, I see it. We're doing okay. Yep.
It's coming?
Yep, it's coming.
Nice.
Woo! Ah, oh, my knee. I'm getting old. So now, as planned, I have full access to take off the blue tape and stuff. And then I can finagle the kind of the layout, the order of the wires here as necessary. Okay, so this is supposed to go in there first. So we have to undo the hard work we just did to put this stupid thing back in because I forgot. I'm stubborn and I figured I could do it myself. So I totally remember back in the day, Eric and I have done the same thing with a car engine. We're doing an engine swap, the whole engine goes in and we're like, okay, yeah, let's go. Wait, what's this part right here? Oh no, whole engine has to come out again, put the thing in. So I'm just creating a little hook so I can come around one of the hydraulic cables or hoses, grab it and pull on it. All right, a little bit more. Push, push, you can do it. More, I don't see it yet.
Yes.
Is that on all the way?
Yeah, we're up against the face.
Haha! Huge progress. That's awesome. Now it's just bolting it up, plugging it in, getting it all dialed in, and I'll pick away at that probably off camera for the next little while. And then put the spindle on and then button it up. There is some weird ordering of the panel that goes here. That's not normally open. I gotta put that on in a certain position before the spindle goes back on. But yeah, this is good. All right guys, back at it again, another day. So I made good progress here. This is all done and tight. Before I put all the paneling back on, I wanna get my head in here, clean away all the chips, all the dirt, make sure the belt is good. So that belt right there is your B-axis belt. And as that rotates, your B-axis, your spindle will turn. And I was playing with the belt. I can actually move the belt a little bit by hand, and this makes micro movements. So there must be a big gear system in here that does that. So it's kind of neat. So what's kind of cool is it doesn't have to be perfectly square up and down when I put it all back together, because we'll just establish a new home position by rotating it. The motor doesn't care. So we put an indicator on it about a test bar for the spindle. So we'll tune it in later. Okay, so as for what's next, I know the stuff in the back has to be taken care of. I gotta plug in these cooling lines, which go right here. So I cut them way too long, which is fine for now. I gotta put the hydraulic line to there. I can do that right now. Gotta put this other hydraulic line to the other fitting in the back. Let's do that right now. These little air lines, I don't know which is which, but I labeled them so I know A to B and A to B on this side. And then Willemin can tell me where they go. And then getting all these wires plugged in. Maybe we can look at the wiring diagram today. But no, I think this is perfect. Let's try to put this one under. All right. Oh, I'm leaking coolant. Oh. Ah. Oh, stop leaking. I must raise it. This is antifreeze.
Like for your car.
Why are you still leaking? I figured raising it. You want to give me another tub?
Yeah.
Well, that was wholly unexpected. Filled 3 tubs, 3 of these guys, of antifreeze. Well, yeah, it's like car antifreeze, but we're using it as a chilling fluid for the spindle. So that's what's going to go through these, is that blue liquid. The spindle's going to get really hot at 30,000 RPM, so you want to chill it, and there's a chiller at the top. It's kind of like an air conditioner that uses refrigerant to chill stuff like an air conditioner does. But it's chilling this fluid, and dropping this fitting down to the bottom must have created a suction, and it just emptied the whole tank from up there. So, bit of a mess I got to clean up here. But that shows me, and I've known this, the fitting they had here is wrong. It was literally just laying here. There's supposed to be a bulkhead fitting with a screw on the other side that keeps it like attached. Maybe now is a good opportunity for me to replace whatever's going on here with the proper bulkhead fitting. So I love having these nice, clean, bright floors, epoxy coated, that we did when we moved in. But it takes work. It takes work to keep them nice, keep them clean. So by every sink, we usually have a big cardboard box where when people dry their hands, towel's still pretty much clean. We throw it in here, and this is our floor cleaning up paper towels. I mean, they're 90% clean. They just have water on them. But you wouldn't use them as sanitary, whatever. But for the floors, it's amazing. It's so nice to have copious amounts of bounty just ready for this kind of stuff. And I think I said it earlier, but I have incredible amounts of respect for the people designing these kind of machines. There's a lot going on. This is from 2004, this machine. Like, that's a long time ago. I mean, not really, but...
I was 8.
Yeah. I don't know how it compares to the new Willemins, but it's not much different than any of the other machines in the shop. It's just older. But technically speaking, you got belts, you got ball screws, you got linear motors, linear rails, servo motors, encoders. It's all kind of, nothing's revolutionary in a lot of machinery. Here, let me think about this. So I got the 2 hydraulic lines in. As we just saw with the big cooling fluid spill, I do want to fix this hose properly before going forward. On my 2 vacuum lines. So the little hoses, these little guys, go in here. Not exactly sure which is which yet, but shouldn't be too hard to figure it out. So you take a little flathead screwdriver, you shove it in, you twist it, and it opens up the little thing, and then you push these pre-terminated pins in, and then you let go. And you're just shoving them in. Not hard to do, I just gotta know which color goes to which hole. 2004, baby.
Oh my god.
Actually, look at that. Comes with a USB and a floppy.
Revolutionary.
Or for you youngsters out there, the save icon. I got to figure out which one we're looking at here. And Willemin told me. Yes, it's kind of like this diagram. You got all the pinouts 1 through 50, and colors, or usually it'll say like red, green, blue, goes to which one. All right, it's the end of the day. I'm going to wrap it there for today, but made a little bit of progress. Pretty happy with that. All right, so it's been 3 months and 1 big haircut since we started filming this video, and it's actually been a month since the scene just before this one. But it is now together and it works. Let's show some sexy B-roll of this thing cutting metal. So about a month ago, the machine was done, but really the past month has been a lot of work of me and the rest of the team putting it back together properly, getting the coolant hooked up, getting the fire trace, fire suppression wired up properly, coolant pump, chiller had to be done, mist collector had to be put on, bar loader still has to be attached a little bit. There's just a lot of little buttoning up that we put into this machine, but it's pretty much, like famous last words, it's done now. Last things I have to do are some little calibration things, set the length and the position of my turning tools, calibrate the probe, which I'm going to do today, and then figure out how to machine the vice jaws, these vice right here, that open and close, and grip onto the part. One of the really, really cool features of this machine is the U-axis vice. That's this thing I'm jogging in and out right here. And I'm gonna move it all the way out and then look up my code, which is, check out my cheat sheet on the side here. As I'm on the phone with Willemin, I've spent probably 10 or 20 hours on the phone with Marcus from Willemin, just learning the machine, figuring it out, fixing the spindle, all that stuff. And whenever he says something, I'd write it down here. So here's my cheat sheet. Bring jaw up, M186. So I'm gonna go MDI M186 end of block insert, and the vise is going to swing up. Here we go. Sweet. Okay. So imagine you're making a part, and then the vise swings up, comes in, grips onto it with a pneumatic vise, not pneumatic, a hydraulic vise, because your part profile is machined into the jaws, and then the machine can chop it off, and then it can lay the vise back down, it can keep milling here, and it can finish your part completely. It lets go of the part, puts it down the chute into the basket on the outside, and then continues machining the next part. It is freaking amazing. I'm so excited to get this thing running. The plan is to machine the pocket clip for our Saga pen, as well as many other things that are coming up. So I'm like, once I calibrate some tools and the probe, I'm ready to start making a part. I've got 2 parts in mind, one alignment pin I need to make for a fixturing project, and then also the clip. So I'm doing it. I'm doing the thing. It's so exciting. It's been a ton of hard work, and it worked. You know, now I can finally be like, okay, the purchase, the well over $100,000 we've put onto this machine so far, and all of the hours, dozens and dozens and dozens and dozens of hours, it's finally coming to fruition, and it's like, it's gonna make a thing now. So, very excited, very, very, very excited. And that's about all I got for you guys. So we'll keep doing more videos in the future as we get more things set up, as I get the clip programmed and installed and working. There'll be some cool stuff coming up. So yeah, thanks for watching. Later.